Now solving equations. First we have to distribute the 3 to everybody. So when I distribute the 3, we get 6x plus 15 plus 7x is equal to 9 plus 3x. Now combine all your variables, these 6x and the 7x, on one side. Now subtract the 3x over. The reason I don't subtract the 13 over is it's going to make my variable negative. So if I subtract the 3x over, we get 10x. If I subtract the 15 over, we get a negative 9. I'm sorry, we get a negative 6. Then I divide by 10. And we are always going to reduce our fractions. So that reduces to negative 3/5. And we can always check this answer for x. It might be a little hard because of the fraction, but it's always a possibility for us. Our next example. Now first I'm going to give you guys the most common mistake. The most common mistake is students want to multiply by 3. And when they multiply by 3, they get what they forget to do is they forget to distribute this 3 to the 2x. So instead of doing that, what I'm going to have you guys do, so instead of doing that, if you have a function who has a fraction, so we have a fraction here minus a 2x. So if you have a fraction with a term being added or subtracted to it, add that term over to the other side. Now what we can do is we can multiply by 3 on both sides. That cancels out that 3. So we're just left with what was in the numerator, and then distribute the 3 to everybody. Now distribute this negative 2 through. And combine your like terms. So if I add the 2x over, we get 8x. And if I subtract the 24 over, we get negative 10. So x is going to equal negative 10 over 8. And I always want you guys to give your answers as improper fractions, but always reduce them, so it's negative 5 over 4. Okay, this next example we need to get rid of. The easiest way to do this is to get rid of what's in the denominator. So figure out between 4, 2, and 3, what's the smallest number that all 3 of those numbers go into? The smallest number is 12. So if we multiply each one of our terms by 12, we're going to cancel out what's in the denominator. 12 and 4 cancels to be 3. So our first term there ends up being 3x. 12 and 1/2 cancels to be a 6. 12 and 3/4, 4 and 12 cancel so that I have a 3. So I really have a 9x plus 8. So if you multiply by essentially the common denominator, or the least common multiple of all those, you get rid of the denominators. Just make sure you're multiplying every single term by that denominator. Okay, so now what we're going to do, I'm going to subtract the 3x over. I'm going to subtract the 8 over. I'm going to divide by 6. And then, as always, we reduce. Okay, when we're solving equations, sometimes we're going to have special types of equations where either we're going to get all solutions. So if you get something like 5 equals 5, that's always true, so it's all solutions. Or if you get something where two things don't equal each other, like 3 equals 4, that's technically no solutions. So on the left side, I'm first going to combine my like terms. And then if I add x to both sides, we get a statement that's never true. So that's why no solutions. On part B, I'm going to distribute the 2 on the left. On the right, I'm going to combine my like terms. So if I were to add 12 to both sides, the 12s would cancel. If I were to subtract 2x to both sides, those would cancel. So essentially, I would get 0 equals 0. Well, that's always true. So that's all solutions, or I like to say a lot of times infinite solutions. Okay, the formula for surface area of a cone is given to us, where L is the slant height and R is the radius. Solve this formula for L, our slant height. So that's our variable. And the reason we do this is, in your science classes, the science teachers expect you to be able to do this a lot. So think of L as your variable and everything else is numbers. So to isolate that L, since something's being added to it, I have to subtract I'm going to need to subtract this term to both sides. Doing the opposite operation that's happening to it. Now, since pi and r are being multiplied to L, I need to divide by those so that I finally get my slant height L equal to s minus pi r squared over pi r. Today we're going to be talking about solving absolute value equations. And remember that absolute value is essentially the distance from 0. So you have two answers when you are solving the absolute value of -4 and the absolute value of 4. You have a point that is -4, that's 4 units from 0, and +4, that's 4 units from 0. That's why when we solve absolute value equations, we're going to have two answers. Okay, solving this equation. Again, first we need to get rid of what's being added or subtracted to this absolute value piece. So we need to add 1 to both sides. So we have 3x minus 4 all over 4 is equal to 10. Now get rid of the 4 on the bottom, so I multiply both sides by 4. That cancels out that 4 on the bottom. So we have 3x minus 4 is equal to 40. Now set up your two equations. 3x minus 4 is equal to a positive 40, or 3x minus 4 is equal to a negative 40. So I add 4 to both sides. X is going to equal 44 over 3. If I add 4 to both sides with our negative, we get negative 36. X is going to be equal to negative 12. So we have our two answers. Next example. Again, isolate this absolute value. I subtract the 5 over. Now be careful here. Remember, this absolute value piece is always positive. You have that equal to a negative number. That's never going to happen. So here we have no solution. No matter what, I'm never going to find a value of t that's going to equal a negative number, because whenever we found absolute value, that's going to be equal to a positive number. And you could always write no solution like that too. Okay, notice in this example how we have a y on both sides. It's very similar to ones we've been doing. We have 8 plus y is equal to the positive version, and 8 plus y equal to the negative version. So I'm going to solve the first one on the left. I'm going to subtract the y over to get y. I'm going to add the 3 over to get 11. Now they give me a little hint. They say check your solutions. So plugging in 8 plus 11, the absolute value of that, does that equal 2 times 11 minus 3? So this is 19 on the left side. I have 22 minus 3 is 19, so that works out. So this is one answer, so I'm going to circle that. Our next one, I'm going to distribute the negative to both terms. Now I'm going to add this 2y over to get 3y. I'm going to subtract the 8 over to get a negative 5. Now I'm going to check this. 8 minus 5/3. Is that going to be equal to 2 times negative 5/3 minus 3? Well, 8 is 24 thirds minus 5/3. That's going to be 19 thirds on the left. On the right, we have negative 10 thirds minus 3, which is 9 thirds. So we get negative 19 over 3. Obviously, a positive is not going to equal a negative, so this is what we call an extraneous solution, so our only answer is 11. Now, that's not always going to happen, but a lot of times that is going to be the case when you have a variable inside the absolute value and outside the absolute value. Okay, our next example. Martin makes exercise weights. For his 5-pound dumbbells, he guarantees the actual weight of the dumbbells is within 0.015 pound of 5 pounds. Write and solve an equation that describes the maximum and minimum weight of his 5-pound dumbbells. Now this is a absolute value equation. The central value is placed inside the symbol, and the range is placed on the other side. So if you think about it, what is our range? What is he guaranteeing they're going to be within? He's guaranteeing they're going to be within 0.15 pounds. What is the central value? Or the value that this range is going to come off of? That's of 5 pounds. So we're going to have x minus 5, our central value, equals 0.15. So now I have two equations. I have x minus 5 is equal to negative 0.15, and x minus 5 is equal to a positive 0.15. So x is going to equal, if I add 5 to both sides, I get 4.85. Oh, that should be a minus sign here. Now if I add 5 for this bottom equation, we get 5.15. So make sure you have units. I have my equation. I will be looking for the equation, and I've written and I've solved. So these are what he guarantees the weights to be between.
Here are your lesson questions. Please make sure your answers to these and your form submission is completed on time.